In this example, we will be estimating the square root of 77 to the nearest 10th place value. To do this, we want to look at perfect squares nearby to 77. An example of this would be 8 squared, which is 64. This is smaller than 77, so we'll try 9 squared. 9 squared is 81. We can see that 77 lies between 64 and 81. So we can write the following inequality. The square root of 64 is less than the square root of 77, which is less than the square root of 81. We can do this because 64 is less than 77, which is less than 81. Now we can rewrite the square root of 64 as 8 because 8 squared is 64. And then we can rewrite the square root of 81 as 9 because 9 squared is 81. Now we can see that the square root of 77 lies between 8 and 9. However, 77 is a lot closer to 81 than it is to 64. So our decimal approximation is probably going to be closer to 9. We can try out values like 8.7 times 8.7 and see how close we can get to 77. 7 times 7 is 49, carry the 4. 8 times 7 is 56, plus 4 is 60. Add our 0. 8 times 7 is 56, carry the 5. And then 8 times 8 is 64, plus 5 is 69. So adding these together, we get 75.69, which is close to 77. But let's see if 8.8 times 8.8 gives us a closer approximation. 8 times 8 is 64, carry the 6. Again, 8 times 8 is 64, plus 6 is 70. We'll add our 0 and then repeat this because it's the same value, 8 multiplied. We add these together, we get 77.44, which we can see is a lot closer to 77 than 75.69 is. So 8.8 is a better approximation of the square root of 77. So we can write our approximation as the square root of 77 is approximated to about 8.8.